Hi everyone, this is David Blakey. The title of this video is Python List Comprehensions. In this video we'll discuss a simple tool in Python that makes life a lot easier once you get familiar with it and start to use it. When you're writing code on a regular basis, anything that can save you time or typing is usually appreciated. But even more than that, list comprehensions distill into one line something that really ought to be thought about as really one thought, and that is the simple algorithm that takes a list and selects from it and or modifies it. Let's look at a simple example. If we have a list with some values, I realize I'm using the same examples that I used in class and that I use in the handout. It's because I don't have the imagination to come up with new ones. And we wanted to modify this list in some way. We could use a loop. If we wanted to modify the list and then create a new list with the modified values, we could start with an empty list and then just append to the list as we go. So you can see what we're doing here. We're taking my list, which has 4 elements, 4 integers. We're creating a new blank list. Then we're looping through my list, modifying the element from my list, that is doubling it in this case, and then appending the new doubled value to the empty list. You can see we've created a new list that also has 4 elements, but each element in the new list will be the same elements from the old list, but doubled. Simple example, not very practical, may not capture your imagination or show you where you'll be using it, but we run into this algorithm all the time. The algorithm of taking an element, modifying it, and creating a new list, or maybe even the same list, writing back to the same list with the modified values. We could, for example, just assign mod list back to my list at the end. If we were interested in changing the elements in place, that's how we would do it. We'd create a new list and then assign it back to the old label, thus in effect seeming to change the old elements in place. It's something that you could conceivably do through a loop, but it's not generally how we do it. We usually create a new list, and that's only because usually for the sake of sort of sanity, as it were, we like to think in terms of creating something fresh rather than trying to modify something in place. Modifying something in place is just naturally can be messier. Anyway, that's how we do it. And if we wanted to do this with a list comprehension, it would be even simpler. It would look like this. Now these two do the exact same thing. Before and after the comment line, they do exactly the same thing. You can see that between the line mod list and through the loop we have 4 lines of code, and with the list comprehension we have 1 line of code. Now let's break this down and talk about exactly how it's doing it. Well, for one thing, we're beginning with my list. So the loop for I in my list, you can see that's actually represented here. For I in my list, and then we have the return value from the loop, which is I times 2. We're doing the exact same thing we're doing in the above. The only difference is instead of appending to the list element by element as we go, we're simply creating a new list in place through the list comprehension and then assigning that entire new list to mod list. Really, the difference between the two is just syntactic at this point. There's nothing that's being done differently here, and we may assume that Python is compiling this into the same form, whether it's the 3 lines or 4 lines above or the 1 line here below. The difference is really for us, for our benefit. It's easier to think this way, and it's easier to read this. If you look at the loop above for I in my list, you have to think about each line and how it applies to the whole. I think my theory is that naturally the brain tends to take each statement separately, and then we apply those statements together into a group to make some new idea, which is that, oh, I see, we're looping through my list and we're appending the doubled value to mod list. That takes a couple of extra thoughts to read and to comprehend this and then to put it together. Whereas in the list comprehension, it's possible to take in all of this at once. I think it is. And if you start to read it and understand list comprehensions right away, that is, you've become familiar with it, I think you'll agree with me that it takes less brain power and less sort of thinking, really, to conceptualize what's going on here in the second line. It's also true of coding as well. When you're coding something and you know you need to do something like this, it becomes easier just to make the jump. Whereas to construct a loop like the one above for I in my list, even I who've done this 1,000 times before, particularly in a classroom situation, have to construct the thing in pieces in my head in order to get the different statements to go together. Whereas I didn't even think twice about doing the list comprehension. I just thought once. So there are 3 parts to each list comprehension. Not all the parts are necessarily there. But I'm going to identify each of the 3 parts. And in this particular one, we have just 2 of the parts. The first is the loop. And in the loop, we identify the control variable. That would be I. So here we can say 3 parts to a list comprehension. Not all 3 may be there. So one is the loop. That's to identify the control variable, and that's where we say for I in my list. Let's get rid of the other example and just put these together here. The first is the loop, and that's the for I in my list part of the list comprehension. The second is the what we'll call the transformation. Let's give it a dramatic term. The transformation, which modifies the control variable and returns the modified value. And that would be I times 2. Change the first one. Identify the control variable and the list for I in my list, right? The transformation, which modifies the control variable and returns the modified value, I times 2. Okay, let's go even further and ask ourselves, what is the third part? Or I'll ask you, what is the third part? It's something called the filtering. And that was a really great horror film. I saw The Filtering. The filtering will select elements to be processed into the new list. And the text for that would be something like, if I is greater than 5. Let's look at that here in this list comprehension. If I is greater than 5. Okay, so the third part. So you see that the first part I'm talking about is the loop part that we're all familiar with for I in my list. That's familiar enough. I times 2 is the modification. That is, any element that comes that is looped through in my list gets multiplied by 2 and returned to the result list, which in this case is mod list. And then there's the filtering. If I is greater than 5. And that is a test, right? That tests to see if I is greater than 5, and thus will not process any elements that are not greater than 5. So you can see that in this case, and if we go ahead and print mod list, you can see that if we run it, we'll get, oops, guess I've got to comment out this whole thing. see, going back to the top. You can see that the result is 12, 14, 16, 18, 20. That is, everything above 5 was multiplied by 2 and returned. So the filter successfully discarded the first 5 elements. Now, list comprehension, as you saw, doesn't have to have a filter. And in fact, it doesn't even have to have a modifier either. We could take this out. I for I in my list, if I is greater than 5. What does that get us? 6, 7, 8, 9, and 10. So you can see that the list comprehension can be used solely for filtering. It can be used solely for modification, or it can be used for both. It can both filter and modify a list. So how is this useful to us? Well, there's a lot of really great things we can do with list comprehensions. But already I hope, just by sort of force of will, that I've convinced you that list comprehensions are good. And the argument for list comprehensions is that they're much simpler to write and to read. Again, multiple lines means we spend more time pasting together statements in our brain to try to come up with an algorithmic understanding. That is, just figuring out what the thing does. And if you've tried to read other people's code, I'm sure you know, it can be laborious to read code. Or if you've gone through the textbook or any other textbook that shows a code, it can be tedious to read code. It's hard. And it's hard to read code because you have to keep a lot of different values and processes in your head at one time. And it can be tedious, and sometimes it's really hard to pull these things together, which is why we have named subroutines, and later on we'll be looking at classes that sequester sections of code into a named process that we can understand easily and quickly. It's as much for humans as it is for the compiler. In fact, it's probably almost entirely for humans that we have subroutines. It just helps us organize our thinking and our code so that we don't get caught up in complexity. And part of the problem with complexity is that when you read code, it's not easy to understand or comprehend everything that's going on. This is why we have complex sorts of bugs that crop up. When we're really not aware of everything that the code is doing, we can't keep track of it all at once. Well, list comprehension, in saving us from having to type 5 or 6 lines of code, is really helping with that complexity in a small way, a small but a very important way. Because anytime you need to do a simple loop that makes a transformation of a list, you want to think about a list comprehension. It's an important thing. It also allows us, list comprehensions allow us to do some simple and easy things that really make life much, much easier and that are very common for us, involving other types of sequences. Other types of sequences like, for example, a file. If we wanted to loop through a file and assign each line to a list, we might do something like this. We might say file lines equals open myfile.text dot readlines, right? That'll get us the file lines in one swoop, right? That'll get us everything to us. But we might go further than that, and perhaps we want to maybe strip every line in file lines. We want to run an R strip on every line to make sure that there's no new line and there's no additional white space at the end. Well, we can do that here. We can say for line in file lines, line equals line.rstrip, creating a new line with rstrip, and then print line. We could do something like that. We could combine these two, as we often should do. If we see an opportunity, we should try to take it and reduce the amount of code that we've got there. So now we're not even creating an intermediate list. We're just looping through the file. We can go even further and do the shorthand for this. I know I haven't emphasized read lines, but that's what we're seeing when we do this shorthand. Go even further. Or we could even use a list comprehension. Now, perhaps we'll say file lines equals empty. Just this would be to serve our purpose here. If our purpose was more than just to print, which it usually is, we might say file lines.append line. So you can see what's going on in this instance. We've got an empty list file lines. We are looping through the file line by line. We're stripping the line, and then we're appending the line to file lines. And now we have a new list of lines that has all of the elements stripped. But we can go further than that using a list comprehension, and say file lines equals line.rstrip for line in open my file.txt. Maybe we'll say ln for ln. Or maybe we'll just say L. Let's just say lines. Okay, just trying to get it on the one line. Lines equals ln.rstrip for ln in open myfile.txt. Same thing as what you see below. Same thing as what you see below. We're opening a file, we're stripping the line, and we're assigning the stripped line to lines. So we're getting every line in the file, and we're getting every line of the file in a nice usable list that we can now loop over later. But we're stripping each line as we go. Very, very simple thing. A simple thing in one line that this is easily memorizable, and you can get used to this. If you were to get used to this, it would just come out of you without really having to think too much about it. You want to open a file and strip every line of its new line, you'll just write something like this. It comes out very, very quickly and very easily. And other developers, I can assure you, are familiar with this form. And when they see it, they'll say, ah. And in one line, they'll say, ah, I see. In one line, they'll read one line and they'll see, ah, I see. Well, maybe we're interested in more than that. Maybe we're interested only in lines that begin with a certain element, or maybe we're interested in any line that doesn't begin with a comment, a hashtag, something like that. Hashtag, a hash mark. If not ln that starts with hash. I think I've mentioned in the handout this example, and also said that when we get to when you start applying regular expressions to this, it can be even better. This is basically saying, and we can do this really here as well. If line not line dot starts with hashtag. Now, there's nothing wrong with the loop that you see below, but you shouldn't say, oh, I'm going to stick with this kind of looping and not use list comprehensions because, I'm not familiar with them and I don't like them. They seem complicated to me. I would recommend that you not do that. I would recommend that you get used to list comprehensions. Number one, they're going to make your coding easier. Number two, when you use them, it sort of signals to other developers that you're familiar with an intermediate feature of Python and you have no problems with it. And then number three, you're going to thank yourself later on when you have to read your own code. I don't know if you've ever been in a situation where you've written some code and then about 3 months, 6 months, 9 months, a year later, you take a look at it and you're like, what the hell was this person thinking? And this person was you a year before. Well, if it hasn't happened to you and you stick with computer science, it will. And you'll get to the point where you'll thank yourself later on for writing clear, easy-to-read code. It's something I've thanked myself for many times in the past. Just looking at code and seeing easily how it works is a great boon. And I can also say that it's a great boon to your teacher when you submit homework that is well written, that is clearly written, is clearly thought out, and doesn't have a lot of excess. So again, we're looking at a list comprehension that can do certain things with a list, can do both filtering and modification, or as we say, transformation in one line. There's lots of other things we can do. We can work with dictionaries as well. When we work with dictionaries, we can work with the keys. Looping through a dictionary is very easy, and we could work with the keys, but we could also work with something called the items. So I'm going to remove this now and talk about dictionary items. I'm probably going to modify this as I go. This isn't a terribly helpful example, probably. What do we get when we use mydict items? I think we went over this in a Python video earlier. If we print mydict items, we're going to see a structure that I've talked about in class that I just want to emphasize. Let's do a clear again and run it again. What sort of structure are we looking at when we look at mydict.items? This is mydict.items. As you can see, all the pairs are there, but they're in a particular type of structure. What sort of structure is the string A with the number 1? What sort of structure is that? Well, you can see it's some sort of sequence, right? And it's a sequence of elements separated by commas. In fact, 2 elements separated by 1 comma and surrounded by parentheses. By now, I hope you can identify that pretty readily as a tuple. Tuple, right? We've looked at 3 different types of structures that are sequences. One is a list that are objects with commas between them, and that's a square bracket. Objects with commas between them, surrounded by a square bracket. We've seen tuples like these two. This A, comma 1. This is objects separated by commas and surrounded by parentheses. And then we have dictionaries, right, which are pairs separated by commas, and each pair separated by a colon and surrounded by curly braces. This is a tuple. But interestingly enough, if you look on the outside, you'll see square brackets, which makes you think it's a list, and then you see commas between. Well, it is a list, but you can see it's a list really nested with tuples inside of it. In fact, it's a list of tuples. There are 4 elements in the outer list, and each element is a tuple. When we look at items like this, it's possible now to work with the items in a way that could be useful to us, and in a way that can be easily done in a list comprehension. Now I'm on the fly trying to think of how I can show this to you. We could, for example, look at these pairs in terms of their value. Maybe we're only interested in those keys that have a value above a certain amount, and maybe we only want to see those keys. In which case, let's say valid keys. I mean, these numbers can be anything. This could be, an employee's salary. Let's just give our employees some really, really low salaries. All right, I'll give them more money. It's an annual salary after all. Poor A only makes $10,000, but maybe we're not interested in them, or maybe we're only interested in the ones that earn less than $25,000. How would we get a list of keys for people that have less than $20,000? Well, we don't have to use items, and we can use just a regular loop, but I'm just going to jump ahead and suggest that there's an easy way to do it using a list comprehension. I'm going to say, let's say I for I in mydict.items if I 1 is less than 25,000. So I'm going to say I0 for I. Now check this out. Let's remember that there are the 3 pieces, right? The 3 pieces to any list comprehension. The first is the loop itself, where we name the control variable and identify the list that we're using. That is for I and mydict items. You're familiar with this from lists and looping through lists. And here we have a list of tuples, as you know. So when I say for I and mydict items, what is I? If you know that items gives you a list of tuples, right? Items gives you a list of tuples. Then what is I? You can pause this if you want to guess. It's important that you understand what I is. What type of object is I? If I were you, and I don't know readily, I would take a pause the video, and think about it for a minute before you answer. For I and mydict items, what is I? What is I? If we're looping through items, what are we looping through? Remember, when we're looping through something, we're looping through a sequence. And if items delivers a sequence of some sort, what sort of sequence does it give us? Okay, it's a sequence, it's a list, right? And it's a list of tuples. So if it's looping through the list of tuples, then it's looping through each individual tuple, one after the other. So I is a tuple. If I is a tuple and we say I sub 0 for I, well, what's I sub 0? It's the first element of each tuple, and thus the key of each pair. You can see that A is a key, C is a key, B is a key, D is a key. So we're returning A or C or B or D for I and my dict items if I subscript 1 is less than 25,000. What's I subscript 1? It's the value associated, right? It's the value associated with the key. It's the second element. And I just realized that this might be confusing now because we didn't print valid keys. So I'll run it again. Okay, now you can see the keys and their new values. So when we say if I sub 1 is less than 25,000, we're saying if the second element of each tuple is less than 25,000, then return the first element of each tuple. So what we should get then is A and B in whatever order. A and B. There they are. So we were able to loop through a dictionary, through a dictionary's items, and examining the first element, the second element of each one as we go. A second form of this, which is even clearer since we don't have to use subscripts, is the idea of unpacking the two elements of each tuple and giving them names. You can see we're saying I for I comma j. Well, that looks maybe a little bit confusing, but if we put the tuple parentheses around it, you can see we're assigning each element of the tuple, that is the key and then the value, to I and j. So we can say I for I comma j in my dict items if j is less than 25,000. We can even go so far as to give them more descriptive names. This should result in the same thing. Now it's even more readable. Give me each ID for ID and salary in my dict items if salary is less than 25,000. I don't know what could be clearer than that. I think it's clearer and much easier to understand than the loop, the regular for loop would be. And I think it's a great way to do simple looping using list comprehensions. So, thank you for watching. I hope you liked it, and as always, please send me any comments that you may have.